Welcome everyone to another lecture on programming in C++. Today we are going to discuss a very important concept of object-oriented programming called inheritance. In this lecture, we are going to talk about inheritance and understand the concept of reusability. Then we are going to explore different type of inheritances available in C++ and how they are implemented in C++. And also we are going to analysis different type of class specifiers, and we are going to talk about virtual classes as well. So let's start. So inheritance allow us to define a class in terms of another class. That means from uh, any existing class we can actually create new class, and that new class can have different properties or new properties, like uh, suppose we have a animal class. Suppose we have an animal class, so it might have some properties. So we can use that particular properties for a class, suppose dog. So we can use those properties and some add new ones. So we can use these properties, and also we can add some new properties to this dog class. So this is what inheritance is. It actually gives us the flexibility to reuse some of the properties or some of the existing classes and their members. So there are two terms related to inheritance. Uh, One is called derived class. So derived class is those classes that actually inherit or that actually uses some of the properties or some of the members of another class. Like in this particular example, so dog becomes a derived class, or they are sometimes called subclass as well. So, and this is called base class or superclass. So what is a base class? So base class is opposite of derived one. So whose or which class's property is going to be inherited or going to be used for a new class or subclass is called a superclass. So in this particular example, animal class is actually a superclass. So let's move into the coding details. So to implement inheritance in C++, we have to follow this syntax. So what is this? So this is class subclass. So we are defining a subclass or derived class. So what we have to do, we have to specify the access mode. So these access modes are similar to that we have learned in class member access mode. So they are called member access mode and these are class access mode. So maybe their names are same, but their working are different based on where they are used. And then we have to specify the base class name. So we must have the base class defined previously before this subclass, like suppose class base class name. We must have this base class name before defining this subclass. So this is the structure of defining a subclass. So a derived class doesn't inherit access to private data members. So we have already learned that private data members uh, were private to that particular class. That means this data members or private data members cannot be accessed from outside the class anyway. But there are different ways to make private members available to inherited class or subclass. We are going to look into that as well. So that's why this protected members actually comes in handy. But the interesting thing is that class or derived class doesn't have access to the private members, but that doesn't mean that in the derived class private data members are not available. They are available, but they cannot be accessed. However, it doesn't inherit. It does inherit a full part of the object which contain any private member which that class declares. That means suppose we have a private member here and the size is int a, and we have nothing here, we have nothing. So suppose this is class a, and we have in class b, suppose we have our own, so int B, suppose. So this has inherited class A, suppose. So this class B has inherited class A. So if we create an object of this class, if we create an object of class B, we will see that in class B we have two integers. That means the size will be 8. The size will be 8 byte. If we create an object of suppose B1, uh, B1, and we try to size of B1, what we will get? We will get 8, because for this integer 4 byte and for this integer 4 byte. So from this example we can actually see that all the members of class A are available in class B, but as int A is private, class B cannot access that particular member. But that doesn't mean that this is not available in class B, but actually hidden from class B. It is available but hidden from class B. So let's take an example. Let's go to the example. So we have this example code that will implement or that will demonstrate the implementation of inheritance. So we have this header files and namespace declaration. Then we have declared a base class called class parent, and we have a, uh, data member here, that is int parent, that is a public data member, because we don't want to demonstrate now or demonstrate, or we don't want to keep any private data member because they are not accessible to the derived class. Then we have a derived class called child, and this public present, so parent. So this is how we can actually inherit a base class. So what we have done here, so just remember the syntax. So it was class keyword, derived class, then colon, then access specifier, then base class name. So base class. So that this things is being followed here. See, as you can see, class. So class. So derived class name is child. Then access specifier. Now there are three type of access specifiers. So they are called at this particular position. So when we use this at inheritance, they are called class access specifier. So class access specifier. So there are three type of class access specifier similar to the member access specifier: private, public, and protected. So we are going to learn about their working in later, but for now, just assume that we have inherited this particular class as public. And one more thing, that whenever we actually inherit a particular class as public, all the properties, all the member properties, like if they are private or if they are protected or if they are public, will remain as it is inside the child class as well. Like this public member will remain public here. That means now this class C, class child, has two data members. One is int p and one is int t. So just let's go to the main. So here we have created an object of class child, and an object of class child has all data members and member function of class parents, to show that we have printed or we have accessed to the uh, C as well as to the P. So we have IDP. So we can easily access this IDP. If they are not inherited, if we don't have this particular syntax here, we could never be accessible, or this particular variable or this particular instance variable will never be accessible by object 1. Object 1 is an object of class child. So we have not created any object of class parent, yet we have an access to this IDP. So we are surely going to run this particular program to see whether actually this particular variable has accessed by this object one of class child. Then we have printed those particular values. So let's just run it. So as you can see, we can easily see child ID is 7 and parent ID is 9 that we have set here. So child ID and parent ID, we have 7 and 91 that has been displayed here. That means we can easily access the data members of another class when that class is being inherited by the new class. That means this new child class has two members now. One is this int idp and another one is this int idpc, and it doesn't mean that parent class also have two data members. Parent class is different. Parent class has only one member. So whenever we create an object of parent class, we can only access this one, but when we create an object of child class, we have access to both the data members, because this child class is inherited all the properties from parent class, and they have implemented this and implemented their own properties actually. So now modes of inheritance. So inheritance or modes of inheritance is used or is actually uh, determined by uh, the class access specifiers that we have said, that private, protected, public. So we have type of inheritance. That means we can inherit publicly, we can inherit protectedly, we can inherit publicly, protectedly, and privately. So in three ways we can inherit some class. So this is the base class member access specifier. So public, protected, private. So in base class we can have three different type of or three different security levels. One is public, another one is protected, and another one is private. So what will happen if we inherit some class as public, like we did in our example? So if we inherit a particular class as public, so public data members will become public, protected data member will become protected, and private data member, they are actually hidden, not accessible, and they are hidden. That means if we further inherit them, so suppose we have a particular class here, say A, and we have inherited this class, or B class has inherited the property of class A, and suppose another class C has inherited the property of B. So this type of inheritance actually determine whether the properties of A will be available in C or will not available in C. And that is how you can actually customize the previous specifiers into your own derived class. Like if we have inherited A as public, so what will happen? Whatever the properties of A is, whatever the public members or protected member of A is, they will remain public and protected. That means they can be easily accessible to C as well. Now, for access specifier, public in base class access specifier, public members are accessible from outside the class using an object. Protected members are only accessible from outside the class by the derived class. That means whoever has derived the class, they can only access this protected member, and private members, they are not accessible through the object or from the derived class. So three level of protection: public is the lowest protection, private is the highest protection, and protected is intermediary between public and private. So now if we actually inherit protectedly, that means if we use the access specifier protected while inheriting, like class B protected class A. So what will happen? All the members of class A, whether it is public or protected, will become protected here. That means they can be inherited as well. That means we can actually inherit the properties of class A to class C as well, because they are protected, and protected members can be inheritable, can be inherited to another class. And now the thirdly, we have this private. So private actually, so what we can do here, we can write private here. So private actually makes everything private. That means the A class or data members of A will become private members of class B. So data member of A will become private member of class B. That means when we inherit the properties of class B to class C, the properties of class A will be hidden in class C, because in class B all the members of class A becomes private. So that is explained by this particular class. So we are going to show, or we are going to see code as well, where these activities are written, uh, but that is not a program, just some code for helping. So here we have a code, we have a class, and this class has three different type of data members. X is public, Y is protected, and Z is private. So this three data members, what will happen if we inherit them as public, as protected, and private? So let's check it out. So this is not a program, so we cannot run this particular program because we don't have any main function written here. So this is just an example code and nothing more. So we have class B and we have inherited A as a public. So whenever we inherit the A as a public, all the data members will become as they are. That means X is public. So X was public. That means in B, X is public. Y was protected. So Y will remain protected in class B as well. And Z is not accessible from B. Z is present in B. Z is present in B, but it is hidden from the access of B. If we inherit class A with a protected specifier, so what will happen? The public member X will become protected. The protected member Y will remain protected, and Z is not accessible. And if you actually use private to actually uh, uh, call a particular class or inherit a particular class, that means everything will become private. So public member X will become private, protected member Y will become private, and private member Z is not accessible. So that is not a case here. So Z is not accessible from the B. So private is default for classes. So if we don't specify anything, like if we write say class E A. So if we don't specify anything, so this A is being inherited privately. So private is by default. The by default inheritance that is supported by C++ is private. That means automatically A will be inherited as a private member, and all the members of class A will become private members of class E. That means further inheritance is not possible. And if there are some functions, if there are some functions in public section or protected section of class A, they will also not be accessible with an object of class E. If we have data members, then no problem. If we don't have any data, if we have data members as well as functions that can actually interact with the outside world, then those functions will be inactive because they cannot be accessed through an object. What we have to do, we have to create our own function, public functions in class E, and then access them through that public functions of class E. So this will happen when actually we inherit publicly, we inherit protectedly, and we inherit privately. Now we are going to see different type of inheritance. So there are five basic type of inheritance. One is single inheritance. That means we have one class and it is inherited by another class. So we have suppose A and we have B, and A is inherited by B. Uh, in multiple inheritance, we have suppose a structure like this, like A, B, and C. And C inherits both the properties of A and B. So something like this. So that is multiple inheritance. That means multiple classes are inherited by a single class. And then we have multi-level inheritance, where uh, a class is inherited, a class a class is inherited by another class, and that particular class is inherited by uh, another class. So this is base class, this is sub base class, and this is derived class. These two are the base classes, and these are the derived class. In hierarchical inheritance, we have something like this. One class is being rated by multiple classes. So it could be like this. So we have one class, suppose A, and it's being inherited by multiple classes, B, C. So B inherited the properties of A, C inherited the properties of A, and D inherited the properties of A. So this is hierarchical, and when we call it hybrid, when we have more than one of these four. So when we have more than two or more type of inheritance work together, then it is called hybrid inheritance. Like this is hierarchical, and with this we add another one, so this is multi-level. So multi-level and hierarchical, both of them together make this hybrid inheritance. So these five types of inheritance are available in C++. So for single inheritance, the syntax is same, class, subclass. So that means we are defining a derived class, and we specify the access modifier and the base class. And also we actually write the code or write the data members and member functions of subclass in this particular class block. So this is the architecture behind. This is the architecture where we have class A, that is the base class, and the properties of class A is being accessed by derived by class B. That's why class B is called the derived class. So let's take a look at the example. So these examples are not real world problems. They are just for explaining what is happening in inheritance and how actually, not how, whether they are accessible to other classes or not. So we have this class vehicle. So that will be our base class, class vehicle. In that base class, we have a constructor of class vehicle, where we have written this is vehicle. And we have a subclass of vehicle class that is called car. And in that car, we have a constructor of uh, class car, where we have written a message car has four wheels. And what we are going to do, we are going to just create an object of car class, not vehicle class. Now the interesting thing is that when a object of derived class is created, automatically, first of all, the objects or the constructor of vehicle class or the base class will be called, and then the constructor of derived class will be called. And if we just run this particular code, as you can see, we have created only one object. We have not created the object of class or base class. But what is happening? The order of execution is, whenever you create a object of derived class, first of all, the object of base class will be created automatically, and that or the members or initial or the instance variables of base class will be created first, and then the instance variable of derived class will be created. So that's why the constructor of base class has been called first. So this is vehicle, and then car has four wheels. So this is how the simple inheritance works. Now let's see multiple inheritance, where we have multiple base classes. So base class 1, that is suppose B, base class 2, that is suppose C, and we have class A. Now how we can actually create this multiple inheritance in C++? The idea is again simple. Just class, derived class. So this is class A, suppose. So this is class A. Then we have to specify our uh, all the classes that we want to inherit in this base class, one after another. So access mode base class 1, access mode base class 2. So in this case, it will be suppose public class A and public, and put a comma, class B. And we can have as many classes as we want to inherit to a single class. So let's check the example. So what is different? So this is the same example, but something is different here. Something is different. That's why this particular statement is working. Something is different. That's why this particular statement is working. That means we can easily access the object. So using the object of class A, sorry, class D, we can easily access the variable A from class A. So what is different here? Here we have this keyword, virtual keyword. So virtual class means inheriting a particular class or a particular base class virtually. Virtually in the sense, uh, physically they will not be available in class B. Whenever we require the data from class A, we can always refer to class A. So there have been, or this, using this virtual keyword, we have actually inherited the properties of class A virtually to class B. Similarly, in the class C, we have inherited the class properties of class A virtually. So using this virtual keyword, we can actually inherit, and this will not actually create any path or any ambiguity in case of accessing the values or accessing the members from D to A, because in B and C, A is virtually available. That means physically it is not available. That means there is no two copies. So this copy that I was showing in say multiple or multiple inheritance, so that copy thing will not happening here. So we have the data members or the member functions of class A is available in class B, but they are not physically available in class B. They are virtually available in class B and class C as well. That's why this particular information is available. That means A or information from class A is available using the object of class D without referring or without using any scope resolution operator or anything. So I guess that is the end of today's class. In the next class, we are going to discuss about this inheritance in details with some real world examples, as well as we are going to discuss about some polymorphism techniques that is used in inheritance, like method overriding, uh, virtual functions, and so on. So stay tuned for that. Thank you, everyone. So this is an example of multiple inheritance. So here we have two classes, two base classes. So first base class is vehicle, like the previous one. And the second base class is called the four-wheeler, where we have written this is a four-wheeler vehicle. So these two vehicles are there, two classes are two base classes are there. And what we are going to do in car class, we are publicly going to inherit vehicle class, and we are publicly going to inherit four-wheeler class. And we also have the car class also have constructor of its own. So when we are going to call this car object, what will happen? So first of all, the constructor of vehicle class will invoke, then constructor of four-wheeler class will be invoked, and then the constructor of car class will be invoked. So that will ensure that yes, from this car class, both the members or all the members of this vehicle class and four class are available. So as you can see, this is vehicle, this is a four-wheeler vehicle, and then car has four wheels. So that is what happening in multiple inheritance. That means we have inherited the car class from both vehicle class and four-wheeler. We can add our own methods. So that is what we are trying to say. We have both the functions available as well as we have our own function. But uh, if we actually create one of the base classes object, then we will have only one of the constructor or one of the constructor available to us. And now we have this multi-level architecture. So I have explained that again. Again, I am explaining it. So we have two base classes. One is intermediate base class, and another one is the original base class. So base we inherit the properties of class C to class B, and then from that we inherit the properties of class B to class A. Now consider this: when inheriting the properties of class B, we are actually inheriting the properties of class C as well, because class B already has the property of class C. That's why class property of class C is also available in class C. Sorry, class A. So let's take an example. So this is how we can actually use it. So we have this base class, uh, that is vehicle class. Then we have this four-wheeler class, but this time we have inherited publicly the vehicle class. That means this class has been inherited publicly here in this particular class. Now, in this particular class, what we have done, we have inherited four-wheeler class. That means it is a three-level architecture. First of all, vehicle, then we have four-wheeler, and from that we have this car. So this is a three level of multi-level inheritance. So if you create an object of class car, you can see that first of all the object of V will be or vehicle will be executed, then the object of F will be executed, and then the object of C will be executed. So let's try it. So as you can see, this is vehicle. Objects with four vehicles are vehicles, and car has four wheels. So that was what we are intended to do. Uh, so now let's once check what will happen uh, if we inherit this particular vehicle in four-wheeler class as private. So what I said, that private members actually inherit all the members of this vehicle class as private, right? And we have the object of car class again, and if we execute it, so this is a vehicle, and objects with four wheelers are vehicle, and cars has four wheels. So the same thing has been printed, even though I have made everything from vehicle class as private, because to create an object of car class, we first have to create an object of four-wheeler class. But what will happen when we try to create an object of four-wheeler class? We must create an object of vehicle class first. So that's why the constructor of vehicle class is called before constructing the object of this. But that doesn't mean that some of the functions, suppose we have uh, suppose we have in public member, we have this member int a, and in here we don't have anything. So if you try to access a here, suppose, while inheriting all the properties of base class as private, yeah, so we get an error. So let me show you the error. So it is saying int a is inaccessible. Why it is inaccessible? Because in class four-wheeler it becomes private. It is public member, but because we have inherited vehicle as a private, so it becomes a private member in this particular scenario, and it is not accessible. Now if we just inherit it either public, then what will happen? Just check it out. We have not get any error, and the car has four wheelers becomes 62. So this is a garbage value, that is that is given by the compiler at the time of instantiation. So as you can see, we have not got any error. Simply, if we have protected, then also we will not get any error. But for case of private, we cannot access. So as you can see, we have not got any error. So for private, uh, this A, access to this A is not available because this A is a public member of in vehicle but becomes a private member in vehicle. But here we have the access. So suppose we are again creating private, and we have seen that there is no access for A here. So what will happen now? Okay, we don't get any error and 62 is printed here. So as you can see that even though we have inherited this public member as private member in vehicle, we have the access to that particular member. Only the private members that is being inherited will not have any access in this class. But these members are private. These members will be treated as private members in this particular class. Uh, so what is the content of this class? This class contains now class four-wheeler contains. So this is a new class that has all the properties of class A. So this has private member int A. So this is the actual structure of this particular class. So this is class four-wheeler. This has private member int A, and this has public members four-wheeler. And it is also vehicle is available here because constructor should always be in the public section. That's why vehicle cannot be private. If vehicle is private, we cannot create and the object of this class. So we will not be able to create an object of four-wheeler class as well. So this is how this particular class looks like. So this becomes private member. So when you inherit the vehicle as public, so this becomes public, nothing else. So all the members in this particular class becomes public. So now let's move into hierarchical inheritance. So this is the architecture, or this is how it might look like. We have one base class, and that base class is being inherited by multiple classes B, C, and D. So A class is inherited by B, C, and D. So let's look at the example. So what we have here, we have this vehicle class again. So it is written this is vehicle, and in the subclasses car and bus, we have not written anything. We have not have anything because you can have anything, but I have not written anything because we want to show that from both the classes we are actually calling the constructor of the base class as well as the constructor of the car class and bus class, but they are not visible here because we have not written anything, any constructor or any other functions in this particular class. So as you can see, this is vehicle and this is vehicle. That means we have created the objects of car first and then object of bus first. That's why when creating car object, we call the base constructor, and when creating bus object, we actually call the base constructor. Now, hybrid inheritance means one or more type of inheritance combined together. So combining hierarchical and multi-level inheritance. So that multiple inheritance. So that why what I show I draw at the first slide. So class vehicle. So we have a vehicle class here. So vehicle suppose. Then we have class fare. So we have class fare. So we have class vehicle, and afterwards we have a car that inherited vehicle. So we have a car here, and we have a bus here. that inherited the property of this as well as this. So this is simple inheritance, or this can be hierarchical inheritance. From one we have two, and this is multiple. So this is multiple inheritance, that where we have two classes are inherited from or in one class. So what will happen here if we create the object of bus class? So what will happen if we create an object of bus class? Only the constructor of vehicle and fare will be executing, and whenever we are creating an object of car class, only the vehicle class or the constructor of vehicle class and then car class vehicle will or car class constructor will uh, invoked. So let's execute it. So we have created the object of bus class. So that's why the constructor calling will be from vehicle first, then base fare from, and then bus. Yeah. So this is vehicle, fare of vehicle, bus, carry people. So these three are the constructor that has been called. Now we have some issues in inheritance as well. So in hybrid inheritance basically. So for that, let's take an example of this particular special case of hybrid inheritance. So this is called multipath inheritance, where we have four classes. So what is here? So A class is inherited by, sorry, A class is inherited by class B, and A class is inherited by class C as well. And B and C are inherited by D. So this is not inheritance. So this is showing that we have a path from A to A, B, and D, and from A, C, and D. So we have two paths. And when we are going to accessing the members of class A from class D, which path we are going to choose? So that will create an ambiguity. So first, I'll let this example. So we have an architecture like this. So we have a class A that has a data member, suppose int A. We have a class B that has inherited class A. So this is class A. So this is class B that has inherited. So here we have B, and we also have class C here that has inherited from class B, and we have C here, and class D has D, it inherited both the classes. So this is the architecture. So class B and class C are publicly inherited by class D. Now what will happen if we create an object of class D? If we create an object of class D, what are the scenarios that may happen? Let's check it. So if we try to access the object of class A using this, they will produce an error. Why? Because there is no way that compiler can determine in which path it should access the class D. Like it can go from D to C, then A. It can go from D to B and A. So there is an ambiguity in the path. That's why these two statements are not going to work. These two statements are not going to work. So what we can do instead, we can mention from where to take that particular value. So either from B class or from C class. So we have to use the scope resolution operator to mention from which class we actually want that particular A value. And for B, C, and D, for object of D, accessing the class or accessing the member of B, accessing the member of C is not a problem, but accessing the member of A is a problem. So this is actually the problem, and this is one of the solutions. So we are going to discuss that. So this is one of the solutions. So what is the problem here? The problem is something like this. We don't have a clear path from A to D. So either we can go from A, B, D, or we can go to A, C, and B. So what is the solution? The solution is one to use scope resolution operator to specify which of the version should be called. Either it should be called the B version or it should be called the a version. And another one, so this we have seen in our example that this is the case. And another process is to use a virtual class. So what is a virtual class? So let's take a look at the example.